Welcome to Linear Functions Video 3. In Part 3 we'll be looking at the standard form of a linear function y equals mx plus c. We'll be talking about developing that standard form from a graph or from a pair of coordinates, and we'll formalize the way that we calculate the y-intercept, as we already know how to calculate the gradient, and then we can put it into this form. So let's first of all have a look at the standard form y equals mx plus c. Y equals mx plus c. So first of all, I just want to point out that y and x are our variables, and this is a relationship between these two variables. X is the independent variable and y is the dependent variable. Y depends on x. Based on what x is equal, we could work out what y is equal to. And of course this also means that m and c are called unknown constants. So they're constants because they, once found, they stay the same throughout for this function throughout. But in some cases we might not know them initially. Now the good news here is that m is actually the gradient. If you know the gradient, then you can put it straight in front of x as the coefficient, and that will be your gradient value because it represents the rate of change of y as compared to x. And this means that when x is 0, we're left with just c. So c is our y-intercept. So if we know the gradient and the y-intercept, it means that we know the function itself, and that's really important. So now let's have a look at how we can develop a standard form of a linear function from a graph. Here's an example. In graph 1, I'm given that green line and a fair few points that it passes through. Here, 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 and here, just for example. So I'm going to choose two of those points to calculate the gradient. And I'll be doing it with 2 points from now on because I feel that's probably the safest way of doing it. So our 2 points are 0, 5, and 2, 1. So the gradient, in this case, is equal to y2 minus y1 over x2 minus x1, which is of course equal to 5 minus 1 over 0 minus 2, which is equal to 4 over negative 2, or equal to negative 2. 4 divided by negative 2 is negative 2. Now notice here as well that this point is the y-intercept, because it's where it passes through the y-axis. So the y-intercept of this function is equal to 5. And based on our standard form, it means that our function is y equals mx plus c. But we know our c value is the y-intercept, and we know our gradient value is the m value. So therefore y equals negative 2x plus 5 is our function. So this is the function version of that graph. And quickly through another example. Here's my second example, and again I find two coordinates. There's one and there's one, and so I have 0, negative 2, and I have 7, 0, and from those two coordinates I can calculate m, the gradient, y2 minus y1 over x2 minus x1, and that's equal to 0 minus negative 2 over 7 minus 0, which is 2/7. And I can also see quite clearly that my y-intercept is negative 2, so c is equal to negative 2, and I get y is equal to 2/7 x minus 2. And that's our function notation for this particular straight line graph. But what about if you're given two coordinates? So let's say we're given the coordinates 0, 6, and 2, 9. Now the good thing here is we're actually further on than the graph. So in the previous example we had to find two coordinates. Now we know the two coordinates. So m is just equal to 9 minus 6 over 2 minus 0, which in this case is equal to 3 over 2. And we're also fortunate in this case because we have the point 0, 6. Well, we know that as x equals 0, this is on the y-axis. So this is the y-intercept, which means that our c value is equal to 6 and y is equal to 3 over 2 x plus 6. Now let's have a look at another example. 3, 7 and negative 2, 11. Now in this example we just follow the same procedures. M is equal to y2 minus y1 over x2 minus x1, which is equal to 11 minus 7 over negative 2 minus 3, and that's equal to 4 over negative 5, or negative 4/5. But in this question we don't have the y-intercept, so we have a little bit of a problem. And in fact I suspect that the y-intercept is not just a nice easy whole number. So here is a formal way of calculating the y-intercept. Once you have the gradient, y is equal to mx plus c, so y is equal to negative 4/5 x plus c. You can use that gradient to calculate the y-intercept by substituting one of your points. So substitute either that one or this one, but only one. One is all that's needed. So I'm going to substitute negative 2, 11, which means that x is equal to negative 2 and y is equal to 11. I know that this function needs to work at this point, so this will give me a solution for c. So my y has become 11 and my x has become negative 2. So here's y is 11 and I swap y for 11, and x is negative 2, so I swapped and x is negative 2, so I swapped x for negative 2. Now all I need to do is solve this equation. So 11 is equal to negative 8/5 plus c, and that's obviously equal to negative 1 3/5. How you choose to do the fractions and deal with that is up to you. I'm going to add add 1 3/5 to both sides, giving me 12 3/5 is equal to c, and so therefore y is now equal to negative 4/5 x plus 12 3/5. So the formal way of solving for the y-intercept, if you know the gradient, is to create that gradient function as we did here, or create the function as we did here where we just don't know c, substitute in a known coordinate, and then solve the equation to calculate our value for c. Put our c value in and conclude with the final function. Thank you.